Hi, and welcome back to Gaffy's Grinds. This is video 3 in our series on energy for junior cycle science. And in today's video, we'll be learning about how we measure energy. The usual reminders before we begin do try and eliminate distractions now by turning off your mobile phone, closing your social media tabs that you have open. Just means you're going to be able to work better without getting distracted. And most importantly, I'm going to ask you to do some things while we're watching the video. I'm going to ask you to speak some answers to the screen. I'm going to ask you to write some things down. I'm going to ask you to do some questions. And if you want to make the most out of your learning time here, it's really, really important that you do things I ask you to do. If you don't, you're not going to learn very much. So I'm guessing that you want to learn. That's why you're here. So maximize that by doing the things I ask you to do. In the previous lesson, we learned about what we mean by an energy transfer. So very quickly, speak your answer to the screen now. What is an energy transfer? 1, 2, 3, go. Okay, I hope you said that energy transfer is when energy moves from one object to another. So we're going to jump straight in. We're going to look at an example. If we have a toaster, when a toaster is on, we have a toaster. When a toaster is on, it's transferring energy to bread. It makes toast. This is bread. We say that energy is transferred. What type of energy transfer is this? Energy transferred from a toaster to some bread to cook the bread. So 1, 3, speak your answer to the screen. 1, 2, 3, what type of energy transfer is this? Okay, I hope you said this type of energy transfer is heating. Now it's really important that scientists and engineers, when they're building things like toasters, that they need to know how much energy is transferred. If they don't know how much energy is transferred, then they won't be able to build a toaster that makes toast properly every time. Sometimes the toaster will make toast perfectly. Sometimes it would still be bread at the end, and sometimes it will be burned really black. So it's really important that scientists were able to work out exactly how much energy gets transferred when you put the toaster on. They're able to set the toaster. So you've got, all toasters have that little wheel on the side that you can change the settings to make like lightly brown toast to very dark brown toast. And again, this is all about needing to know exactly how much energy is getting transferred. Then they'll build a better toaster. Now, if they want to know how much energy is transferred, so the question is, how much energy? Well, to figure that out, they need to think about how energy is measured. So we can measure energy. So we can measure it. That's how we can find out how much energy is getting transferred. We can measure it. Now, there's lots of things in science that we can measure. So energy is just one of those things. So energy is something that can be measured. We can measure how much energy is being transferred. Something that can be measured in science, we call this a quantity. Quantity. So quantity is something that we can measure, and energy is a quantity. So a quantity is something that can be measured. Energy is a quantity. All right, so what I want you to do is I want you to pause the video and take down that definition of a quantity. What is a quantity? It's something that can be measured. So pause the video, take that down now, please. Okay, so you should only be watching if you've taken a note of what a quantity is. Now, this is like if you wanted to measure somebody's height. If you wanted to measure somebody's height, you would measure the distance, sorry about that now, keeps correcting what I'm writing. You would measure the distance between somebody's foot and the top of their head. We say we would measure the distance. Now we call that a height. You say somebody's height, but really what you're doing is you're measuring how far is it, or what is the distance between the foot and the top of their head. That would be their height, but it's the quantity we measure is distance. So distance is a quantity. You can measure somebody's mass, which basically tells you how much of a person there is there. In other words, how much stuff they're made of, how much atoms. So somebody who is a bigger, taller person is going to be made of more atoms, obviously. it has to come from somewhere. The height, the extra height, they've got more atoms. Somebody who's kind of a little bit bigger, if you like, I don't want to use the wrong word here, but if somebody's a bit heavier, they've got more atoms, and more cells make them up, so more stuff. So their mass would be higher, and we can measure that. We could also measure somebody's temperature to find out maybe if they're ill or not. These are things that you guys will be familiar with measuring. So somebody's height, or the distance between the foot and her head, somebody's mass, you measure that when you get on a scales, and somebody's temperature, you measure with a thermometer. Energy is just another one of these things that you can measure, energy. And these things, distance, mass, temperature, and energy, all of these are what we call quantities. So a quantity is just something you can measure. So you've got 4 quantities listed here. Now, sometimes, instead of writing this word out every time, we can shorten the word. So instead of using the word distance every time, in science, scientists like to be lazy and take shortcuts sometimes. So we have what we call symbols, which are basically shortened versions of these words. So for distance, for example, we often use the symbol lowercase d. For mass, the symbol for mass, to show for scientists to communicate that they're measuring mass, they would use a lowercase m. Now, why do they use lowercase d and m? Well, there's probably already some other quantity that uses a capital D and a capital M. So they can't use them as well. So instead of mixing them up, these are lowercase. Temperature, its symbol is a capital T. So why is it capital? Well, it was probably the first one to use the symbol T. Another one that would use the symbol T would be time, and time uses a lowercase t. So you see why sometimes we use capitals and lowercases to show 2 different things. Well, the symbol for energy is a capital E. So these things are what we call symbols. A symbol is just a shortened way of writing a quantity. That's what a symbol is, a shortened way of writing a quantity. So little d for distance, little m for mass, little t for temperature, and big T for temperature, and capital E for energy. Capital T for temperature, capital T, capital E for energy. Now, when we measure these things, we have something that we call a unit. So each quantity has its own unit. And the unit will tell us, when we see a number, it will tell us what the number represents. So for example, the unit for distance would be, the standard one we would use is the meter. So we would use meters to measure distance. So instead of just saying, what's the distance from here to the, from your house down to the main road, you wouldn't just say, oh, it's 5, because that doesn't really tell people what you're talking about. You need to say 5 meters. Okay, so it's 5 meters from my front door to the road. That lets people know straight away, okay, it's 5, and they're talking about distance, so it's meters. So this is what we call the unit. The unit for mass would be kilogram. We would use the kilogram. So things, the mass of things is measured in kilograms. So we often talk about a bag of potatoes, is the big bags you can get in the shop. That's normally about 10 kilograms. So you wouldn't just say, oh, the mass is 10. You need to you need to use the unit so people know what you're talking about. Temperature, we would measure in a unit called degrees Celsius. I'm guessing you guys are mostly familiar with these 3 units, the meter, the kilogram, and the degrees Celsius. The unit for energy is probably a new one. Okay, so you probably haven't heard this one before, so paying attention closely. The unit for energy is the joule, Joule, joule. So joules, we measure energy in joules. So kilograms to mass is the same as joules to energy. Or degrees Celsius for temperature is the same as joules for energy. So they are the unit. Now, like I told you before, over here, these guys, these were symbols for the quantity. So capital E was the symbol for energy. Sometimes, again, because I told you scientists are lazy, they like to have symbols for the units as well. So, for example, instead of writing the full word meter, scientists would actually sometimes write just little m. For kilogram, instead of writing the full word, they would use the symbol kg, lowercase. For degrees Celsius, you may have seen it written like this before. It's like a little zero up here. This little zero means degrees, and then a capital C, so degrees Celsius. And joules is a capital J. These things are what we call unit symbols. So meter, kilogram, so M, kg, degrees C, and capital J are what we call unit symbol. So the main thing I don't want you to do here is I don't want you to mix up the unit symbols with these guys. These are the symbols for the quantities. Okay, whereas these are the symbols for the units. Just shortened ways of writing units or shortened ways of writing quantities. That's the one thing I don't want to mix up. An example of how we write this, okay, what I want you to do is I'm going to do the first one for you, example. So what we're going to do is say we had a distance, we were measuring the distance from your front door to the road, and we found out it's exactly 10 meters. So how we would write this is we would write 10 m, like this, 10 meters for short. Now what I'm going to do now is I'm going to get to pause the video, and I'm going to take down everything that I have here. I'm going to take down everything that I have as notes. And when you do that, then I want, so do that first, and then I'll tell you what to do next. So do that, pause the video and do that. So you should only be watching if you've taken that down as examples of quantities. What I want you to do now is I want you to write down how would we write if you stood on the scales and you found out that your mass was 70 kilograms, how would you write that down, please, using the unit symbol? So write that down for me here underneath 10 meters. Pause the video and do that. Okay, this is what you should have, 70 kg. It is that simple. Okay. Now, the next thing I want you to imagine that you've just got coronavirus. Oh, hopefully that never happens to any of us, but imagine that you have. How does the doctor know? Well, he's taking your temperature and he sees that it's very high. So what is a high temperature for a human? 39 degrees Celsius. So I want you to write down, what would a doctor write down in his report? What was your temperature? Right, pause the video and write it down under 70 kg. 39 degrees Celsius, remember? Okay, so you should only be playing the video if you try to write this down. It should be written like this, 39 degrees C, like this. Okay, last one. I want to imagine that the toaster is making toast, and you put the toaster down, and a few seconds later it pops up, and you've got toast, and you measured it, and you found out that 1,000 joules of energy was transferred. So how would you write this down? Pause the video and write it down for me. Okay, this is what you should have had. 1,000, one with 3 zeros, capital J. That would be 1,000 joules. Well done. If you got that right, if you got those right, do tick them now to show that you got them right. Excellent, good job. And you're ready to do some practice. So here I have for you 4 questions. Just do 1 to 4 for me. I want to pause the video, do questions 1 to 4. Okay, so you should only be watching the video if you've done questions 1 to 4. Which quantity is measured in degrees Celsius? So let's look at the question here. Check the question carefully. Which quantity? So we need to name a quantity. Quantity was measured in degrees Celsius. That would be temperature. So well done. If you wrote temperature, that is correct. Temperature is measured in degrees Celsius. Don't forget, I always encourage you should write a full sentence because that helps you improve your scientific writing and improves you to link ideas together. So temperature is measured in degrees Celsius. That should be the full sentence that you should have. Next one, what is the symbol? So you're writing about a symbol for energy. Okay, what you should have had here is, and again, you should have a full sentence. If you don't have a full sentence, you need to make sure you do have one. The symbol for energy is, and it's a capital E. A symbol for energy is a capital E, like this. That's a symbol for energy. What is the unit and unit symbol for energy? Now, careful. It's the unit and the unit symbol. So we already talked about the symbol for the quantity energy was E. So the unit symbol is not going to be E. So if you wrote E, you need to stop, pause the video and think again. The unit symbol. Okay, so what you should have here is the unit of energy is the joule, and the unit symbol for the joule is a capital J. So well done. If you had that, joule and capital J, you should have a full sentence for your answer though. Number 4, what are the unit and unit symbol for mass? Okay, so same type of question as number 3. So if you didn't get number 3 right, now you know how to do number 3. Pause the video, do number 4 now. Okay, what you should have had is the unit for mass is the kilogram, and the unit symbol for the kilogram is kg. Okay, so the unit for mass is the kilogram, and the unit symbol for kilogram is kg. Okay, we're now going to learn about how to read a scale. Now, why do we need to learn about how to read a scale? Well, we need to learn how to read a scale because when we measure things, we usually use pieces of equipment or tools in science. And it's important that when we're using tools, that we know how to read them. And part of that is learning how to use a scale. So I'm going to show you, I'm going to draw here a simple scale. So I'm going to start with a line. Most scales are just a line. Now, there might be a straight line. Sometimes it might go around in a circle, but they're still the same kind of idea. So let's start here. Let's say this is the beginning of the scale, and this number here is 0. Then we have 5, 10, 15, 15, 20, 25. Okay. Now, say we wanted to know, just by looking at the scale, there's obviously some numbers here. It goes from 0, 5, 10, 15, 20, 25, and so on. The first thing to know is what is the gap between these two numbers? So what I mean here is what's the difference? How much has it changed by? Well, from 15 to 20, that has changed by 5. To go from 15 to 20, it's gone up by 5. And we want to find out what each of these little lines is worth. That's how a scale works. Even though each little line here is not shown its value, because otherwise it would take too long to write every single number, we still need to be able to work out what each of those little points would be. So how many spaces has this part of the line been divided into? Well, here you can see there's 1 space, 2 spaces, 3 spaces, 4 spaces, and 5 spaces. So this gap here was worth 5 units from 15 to 20, and there are 5 little squares. So 5 divided by 5, because there are 5 squares, equals 1. So each little square is worth 1 on this scale. So with that in mind, that tells me, well, if this number was 15, then this one after here is 16 because it went up by 1. Then the next one is 17, 18, 19, and then 20. So that is how this scale works. This is a very simple one. All right, I'm going to get you now to tell me what number would this be then? How many would you have if I was pointing at this number here? All right, so I want you to pause the video, write down your answer. What would this number be? Okay, hope that you said that this is 11. So well done if you worked that out. We know this because each square on this scale is worth 1. So if this one is 10, then the next one has to be 11. What about this one? Pause the video, write down your answer. So you can call this A and you can call this B if you like. So A equals 11, B equals what? Pause the video. Okay, I'm hoping that you said B is equal to 3. Okay, because if this is 1, this is 2, and this is 3. Okay, well done. Now we're going to make it a little bit more complicated because that one was really easy. We're going to make it a little bit more complicated now. I'm going to draw another scale. Again, just a straight line. This. And we're going to start. I'm just going to go all the way to the edge here. There. start here, say that this is 0, 10, 20, 30, 40, 50. Now, as you can see, this one is a little bit different because it doesn't go up in 5s, it goes up in 10s. So every gap here, instead of being from 0 to 5 and then 5 to 10, it goes up in 10s. So the gap here, or the difference, is 10. Now, obviously, the difference from here to here, 10 to 20, is also 10. That's how a scale works. It has to go up by the same amount every time. 20 to 30, the difference is 10. Now, again, if we wanted to know what each of the little squares here is, well, we need to work out what each space is worth. Again, there are 1, 2, 3, 4, 5 squares between 0 and 10. So if we take 10 and divide by 5, we will know each square is worth 2. 10 divided by 5. You can use your calculator to work that out. Generally, scales are pretty simple to work out. It just takes practice. And once you do it, you can figure it out pretty much by looking at it. But just for the beginning, I'm going to really show you in detail how we work out what each little square is worth. So each little square is worth 2. Then what does that mean? Well, that means that this first little line here is going to be 2, 0, 2. The next one's going to be 4, then go up by 2 again, 6, and then go up by 2, 8, and then go up by 2, 10. Now, again, you'll know if you're right because you should be, the numbers in pink should still be correct on the scale. So 0, 2, 4, 6, 8, 10. That's correct. All right. You do this one for me. What would this one be? So you can call this C. So write down C equals what? Pause the video and do that now. Okay, I'm hoping that you said C equals 24. If you said C equals 24, well done. If not, if you said C equals 22, then you're doing it wrong because you are saying each gap is worth 1. Now, if each gap was only worth 1, then this would be 21, this would be 22, this will be 23, this will be 24, and then this one you would expect to be 25, not 30. But it isn't, so it's gone up to 30. So each square has to be worth 2. I hope you see how that works. Okay, you do this one for me again. So this one here, you can call this one D. D equals. Pause the video, write down your answer. Okay, this here, D, should be equal to 36. Well done, got that right, excellent. Again, we're going to make it a little bit more complicated. All right, so say this here is 0 and going up, we have and say that this scale is measuring for us kilograms. So it's on a piece of equipment that measures kilograms. Now, the first thing we need to do is find out what is the gap, how much does it go up by, and then find out what each square is worth. And when we do that, then it might allow us to figure out what is this here, question mark. So pause the video and write down your answer. This one here, we call it, actually, we're going to call it E. So we're trying to keep letters on. So this is going to E equals what? Now, don't forget to include the unit. So you need to write down the number and the unit. Remember what we're measuring? We're measuring kgs. So pause the video and do that now. Okay, I'm hoping, actually, I'm going to show you how I did it first. The gap between 0 and 10, it's going up by 10. So this space is worth 10 kgs. 10 to 20, again, it goes up by 10. 20 to 30, it goes up by 10. You see the scale has to go up by 10 every time. So let's find out how much each little square is worth then. Well, 10, there are 2 squares between 10 and 20. 10 divided by 2 is equal to 5. So each square is worth 5 kgs. So that means that this here is 5. 0, 5, 10. What would this one be? Hopefully it said 15, then 20, then 25, and so on. So E then, I'm hoping that you said, is 55. If it said 55, well done. It's not the final answer though, because don't forget what we're measuring. We're measuring 55 kgs. Great. Well done. You said 55 kgs. That is correct. Excellent. Right, the last one, before we do some practice. And again, it's going to be even a little bit more complicated. So we're making it a little bit more complicated each time. I'm going to start again at 0 and okay, so this here is 1.0, this one here is 2, and this is measuring joules. Okay, so this is a scale that measures joules. Now this one is a little bit harder. Let me show you why. This one, let's find out what the gap is, first of all. Well, from here up to here, the difference is 1.0. It's 1. Now, how many squares are there? Let's count them. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So we need to divide this by 10. When you do 1 divided by 10, if you get your calculator and press pause in the video, get your calculator and do 1 divided by 10 now, please. Okay, when you do that, you're going to get 0.1. That means each little square is what? 0.1. So when we check this out, this little line here, for instance, is what? 0.1. Then we go up by 0.1 again, it's going to go to 0.2. This one's going to go to 0.3 and so on, 0.4. And then this one in between 0 and 1 is going to be 0.5. And that makes sense because 0.5 is a half of 1. But what I want to know is pause the video and tell me this one here. What is this one? So you can call this F. F equals what? Pause the video and write it down. Okay. I hope you have an answer. Don't forget now to pause the video again if you haven't and put down the unit. What is the unit? If you didn't have a unit, you can pause the video and put the unit on, please. Okay, I'm hoping that you said that this is 1.3 joules. If you said 1.3 joules, well done, correct. Right, ready to do some practice. Okay, here we've got some pieces of science equipment. And what you have to do is you have to write down, you can call them A, B, C, D, and E. I want to write down what measurement do they show and what units are they in. Now, this is temperature, just in case you're not sure. This is a thermometer, so it's measuring temperature. So you'll get the unit from that. Okay, so pause the video, write down your answers. Okay, so you should only be playing the video if you've tried to do each of these. The first one, well, I'm halfway between 60 and 70. There are 2 spaces between 60 and 70. So in the middle of them is going to be 65, and the unit is kg. Well done. If you said that, great. The next one I think is the hardest one, the temperature one. Okay, so if you see here, we've got a scale. The scale goes from 10 to 20 to 30. And in each one, there's 5 squares basically between 20 and 30. So each little square, the difference is 10. And there are 5 squares. So 10 divided by 2 equals. Okay, so each little space, sorry about that, each little space is what 2. So if it's 20 to 30 and there's 5 little spaces in between, then each space is what 2. This is on the first little notch here, or the first little space. So this should be 22 degrees Celsius. Well done if you got that right. If not, I hope you can see why now. It's on the first little space, and there's 5 spaces between 20 and 30, so that's going to be 22. The next one, well, we're exactly, sorry about that, we're about exactly halfway between 1 and 2. So that's going to be 1.5, and the units are here, look, so 1.5 kgs. The next one, look, the units are degrees Celsius. This is 200. This is 250, so the gap here is 50. There are 1, 2, 3, 4, 5, 6, 7. There are 10 little squares. So each little square is worth 5 here. So this is going to be, this is 8 squares up. So this is going to be 240 degrees Celsius. Well done if you got that right. If you said 2, what else might you have said there? We said 235 or 245, then I think that that's just a case of not looking carefully enough at the scale. Okay, last one, we've got kilograms. So here's 1, 2, 3, and between each one, there are 10 little squares. So each little square is going to be what? 0.1. So this is 3.1, 3.2, 3.3, and this is 3.4. So well done. If you said 3.4 kgs, that is correct. Well done. All right, so you now know how to read a scale, and you know what a quantity is, and you know what a unit is. So a quantity is something that can be measured. A unit is how we measure things. So we measure distance in meters, we measure mass in kilograms. The new one today, energy, is measured in joules. You know how to read a scale, so now you'll be able to use pieces of equipment when we're back in school and we're doing experiments. You'll be able to read the scale and figure out what the scale is telling you is the measurement of whatever quantity it is that you're measuring. All right, thanks for watching the video. I'll see you in the next one.